In this video, I am going to show you how to find the inverse of a logarithmic function. But first, I need to make sure you understand two more basic concepts that we're going to need. The first one is just how to find the inverse in general. So before we get into logarithmic functions, imagine that I had the function, let's say, f of x is equal to 2x plus 3, simple linear function. Now this would be the same thing as y equals 2x plus 3. So to find the inverse function, you do two things. You switch x and y, and then you solve for y. I'm just going to repeat that. Switch x and y, solve for y. So first of all, I switch x and y. So the x goes here, the y goes there, and then I'm solving for y. So if I would subtract the 3, so now I have x minus 3 is equal to 2y, and then I would divide by 2. Okay, so now I have x minus 3 over 2 is equal to y. So there I have solved for y. Now I can put this back in function notation with the f of x, but I need to put this little apostrophe in there. Okay, and I'm going to rewrite it from left to right. So this would be the inverse of function f, and the little apostrophe shows that it's the inverse. So that's the first concept I had to remind you of. How do you find the inverse in general? Switch x and y, solve for y. Now here's the second concept that we're going to need to deal with logarithms. You need to memorize how to switch back and forth between exponent form and log form. So for example, I'm just going to use a, b, and c. If I have a equals b to the c power, this is called exponent form. We have a base and power. Now, in logarithm form, obviously there will be a logarithm in it. Now, focus on the base, the b, all right? The base is the key to everything. So in logarithm form, you write your log, and then that base goes here. See how it's hanging low? It is a subscript. So log base b. Now the a and the c are basically going to switch places. So the c is going to come over here, and the a is going to come over here. So exponent form, log form. All right, you need to be able to go in the other direction too. Let's see, here's something in log form. Say if I have p is equal to log base q of n. All right, I should be able to rewrite this in exponent form. Now again, focus on the base. The q is the base. So, and I'm going to keep this q on the same side, and I'm going to write it as a base. So in exponent form, you have a base, and it gets a power. Now what power? Now the p and the n switch sides. So the n is going to wind up over here, and the p is going to wind up over here, but now it's going to be the exponent. So this would be the exponent form. All right, now we're ready to find the inverse of logarithmic expressions. So here we must find the inverse of this logarithmic function. So to find the inverse, the first two steps are we need to switch x and y, and then we need to solve for y. So if I switch x and y, then I get x equals log base 2 of negative 2y. So now I just need to solve this for y. Now, most of the time to solve for y, you're going to have to rewrite this in exponent form. So again, the way you write this in exponent form, focus on the base, which in this case is the 2, and you bring that base down. Now, these other two things are going to switch sides. So this negative 2y is going to end up over here. All right, this x is going to end up over here, but in exponent form, it becomes the exponent. So again, I'm trying to get y by itself, so I switched x and y. I messed up the grammar there, but now I'm solving for y. So to get y by itself, I just need to divide both sides by -2. So this really is going to give me the answer, which is going to be y equals 2 to the x power over -2. So that is the same as b here. Notice I can't cancel out these 2's because this has an exponent. They just took this negative sign and stuck it here in the middle, which is no different. So the answer is B.